Hey folks, welcome back to another video. Today we're looking at question 1608, special array with x elements greater than or equal to x. The way we'll be solving this problem is by keeping a track of all of the elements in the array that's given to us with a little catch. And let's talk about the catch now. So basically, there needs to exist a number x such that there are exactly x numbers in the array that are greater than or equal to x. Right? So what are the values that x can take? Because it has to, there have to be x number of elements in the array that are greater than or equal to the maximum value that x can take is equal to the number of elements in the array, right? Number of elements in the array. So basically, if we have the max value of x to be the number of elements that are in the array, we can have the number, the frequency, just counting all the numbers from 0 to x minus 1, and everything that is equal to x or greater than x can be stored in the last element. So with that, let's create the frequency array. So int x would be equal to, let's just call this max, and max x could be equal to nums.length, right? And for the frequency array, because we start with the 0th index, we need to increment it by 1, so it would be new int of max plus 1, right? So the last element will be counting the frequency of the maximum, anything that comes after x, which is in our case, we're assuming that the maximum value of x can be the number of elements in the array. So anything that is equal to or greater than the length of the array itself will be stored in the last index. So let's do that right now. So let's count the frequency. We have to go through all of the numbers in the nums array. So int num in numbers. So if num is greater than or equal to max, we will increment frequency of max plus plus, right? Else it would be frequency of the element itself plus plus. Awesome. So the next thing that we need to do is we need to find the number of elements that are exactly equal to x or greater than x. So since the elements that are greater than x will increase if we go from left to right, let's start from right to left instead. So it'll be if for int I will be equal to max, I is greater than 0, you decrement I, right? And we need a counter of sorts. So this will keep a track of the number of elements that are greater than or equal to x, since we are going from right to left. So what this will do is you'd increment that by the current index that you're looking at. So this would be I. So if the current I is equal to the count or the result, it basically means that we have found an element that has numbers that are greater than or equal to x. So that's when we actually return the value I. If we go through the entire array and we don't find that value, we just return -1, because there are some cases that don't match that. For example, when we have zeros in it, right? So let's try compiling this. The first few test cases are okay. Let's try submitting it. Awesome. Everything else is okay as well. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we are iterating through the entire array twice, but it would still be of n. Space complexity is of n as well, since we are using a new array to store the frequency. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.